Alrighty, welcome back. Now we are on lesson 10 and 11. And so lesson 10 and 11 really start to build and bridge connections between our equations and our graphs together. And so we were talking about how to represent equivalent functions, and that's going to come back into this as we talk about how the way the different forms of our linear equations relate to our graphs, and how some forms can be easier to help you graph and other forms can help you with other things that you're working on as well, to solve for variables and things we've talked about over the past couple of lessons. And so we have a lot of vocabulary for this lesson, right? We're talking about linear equations. We're going to talk about slope, what a y-intercept means, what a coefficient represents, slope-intercept form, and standard form. All of these are important words that will pertain to what it means to graph an equation. And so in the second slide, right, you're going to take a look at practicing writing equations. Again, remember, this has just been a review consistently from our first lesson in this unit. And so you're going to take a look at how I can create an equation. Just good warm-up practice, right? So when it comes to 10.2 is when we start to get into our material for this unit, this lesson, right? The equation below represents the relationship between the number of games and the number of rides and the dollar amount a student is spending on games and rides at a different amusement park. So our equation is given x plus y equals 20. And x represents the number of rides. Remember, practicing reading our equations. X represents the number of rides. Oops, sorry. X represents the number of games. I was reading it the other way. X represents the number of games. And Y represents the number of rides. And so what if we don't play any games? So that means my X in this instance is 0, right? I play no games. And so, okay, so let's take a look at my equation. I know that if I play no games, that means 5x plus y is equal to 20. And that I know that 0 plus y is equal to 20, which just means y is equal to 20. And so I have the point x equals 0, y equals 20, or I can be written as a coordinate point, 0, 20. And then we can graph the point on the line, right? 0 is my x, and then I'm only going up to my 20, which is y. So this is my point, right? This is 0, 20. On the other hand, if I don't go on any rides, then I can use up my money instead on spending it on games. And therefore my y equals 0. And so if I have y equals 0, 20, so x plus 0 equals 20, that means x also equals 20. So I know I have the point x equals 20, y equals 0, which would be the point 20 comma 0, right? Remember, think about our coordinate points from before. And so that would be the point, right? That would be the point. Let's make it orange here, right? This is the point, what was it? 20, 0. And so, all right, so now I can draw a line connecting those 2 points because I realize that these two are two solutions to my equation. And so any point on this line is also a solution to the equation. Obviously, this is a sketch, so it's not going to be a perfect one, but we can also check how our graph looks out, right? If I choose a point, let's choose 10, 10, right? It looks like it's on the line, 10, 10. If I substitute in 10 and for x and 10 and for y, that gives me 20, exactly what I'm looking for. And so this is a sketch, but it gives a pretty solid sketch of how you can graph a line and what those things represent. And so from what we know now, our the first point that we found is our y-intercept. It intercepts the y-axis. Intercept. This is our y-intercept. It intercepts the y-axis. On the other side, we have our x-intercept. Right, this is where it intercepts the x-axis when y equals 0. Y-intercept is when x equals 0, and it intercepts our y-axis. And then we have our x-intercept that intercepts the x-axis, so it's when y equals 0. And so that's super helpful when you are graphing your equations and figuring out how to create your equations that way. So then moving forward, right, then we start to want to build a relationship between the graph itself and properties of the graph, right? So if the student played no games, they can get on 20 rides, right? We were able to see that. For every additional game the student plays, the possible number of rides increases or decreases, right? So if they played 0 games, right? If they played 0 games, that means that as they play more and more games, right? If they start off with playing 0 games here, as they play more and more games, right, we're looking that way, we notice that it's decreasing, right? We know that we can see that our graph is decreasing, and so we know that it is decreasing by a factor of 1. And we can see that by looking at the graph, right? I notice that as I'm going along, and you can look at your 10.2, right? If I'm at 1 game, this is 1-19. I know if I have 2 games, this is 1-18. And you know that, 2-18. And you know that because you can see the relationship between x and y equals 20, right? So 1 plus 19 gives me 20. 2 plus 18 equals 20, right? So each time I increase my number of games, I'm decreasing my number of rides that I can go on. And if you're ever stuck, you can also create a table, right? XY table. 0 gives me 20, 1 gives me 19, 2 gives me 18. A table is a perfect way to see how to graph your equation. And so then the question is, what is the slope of the graph? The y-intercept we found just previously. And so the slope of the graph represents the gradient, which is the number that describes the direction and the steepness of the graph. And so some of you may have been introduced to slope before, but slope is really hold on, where aren't you coming? The slope we sometimes represent as m. Let me close this for a sec. Represents as m is equal to the change in y over the change in x. Right, so I notice that each time I go to a different point, I am decreasing by 1. Right, I'm decreasing by 1. And so the formula that you may have been familiar with was y2 minus y1 over x2 minus x1. x1 and y1 are 2 points, x2 and y2 are 2 points that are on the graph. So you can use it to be 0, -20 or 20, 0 as your 2 numbers, right? If you were to do this algebraically, right, you can see that this is, if I choose 2 points, this is 20, right, from this 20 minus 0, right, from this 0, all over 0 minus 20. And so algebraically, you can see that this is 20 over -20, which gives me 1. But we're able to reason that out from our table previously and from just looking at the graph, right? We're saying that this is decreasing, it's going down, and the slope is a negative slope, right? This is -1. And so you're going to start to explore what those things represent, and that's why the definitions are super important, right? Where does a graph intersect the vertical axis is something we talked about right before. And so when it comes to then taking a look at your original equation, try to rewrite the equation solving for y. and see what you notice between the new equation and the graph. What are some patterns you notice? Where do you see slope? Where do you see that y-intercept come from? And so that's going to be more and more important. And then when you get to 11.2, now you're given an equation and a graph and looking for where you see the patterns. Where does that 450 come from? Where does that negative 20t come from? And so take a look closely at that graph and see what's happening. Right? In the same way that this is another representation of an equation, similar to what we saw just previously, but this is written in standard form. And so think about what the definition of standard form is and how you can see where your 6x, your 9y, and the 72 can be found in your equation for the second graph. And so we'll talk about this more in class, but just start to explore those things. And last but not least, just some extra practice with sorting out your equations and seeing what your slope is and your y-intercept. Slope is usually represented by an m. So that is your slope and then your y-intercept. Remember, if you're struggling with anything, make a table, right? If you don't know what the slope and the y-intercept is just by looking at it, you can either rearrange setting y equal to 0, which is our slope-intercept form, or create a table, right? I have my x and my y. Let's see what's happening. If I have x equals 0, what is my y? If I have x equals 1, what is my y? If x equals 2, what is my y? And that should hopefully help you with figuring out what the slope and the y-intercept are. And so as always, if you have any questions about any of this, because I know it's a lot more vocabulary, make sure you read through the lesson summaries and reach out if you have any questions. I'll see you in the next lesson.